This is the final review for physical science, and what I've done is I originally had 4 pages of this for the normal final exam, but I'm cutting a lot of things out to make it simpler, and therefore this is only going to be 3 pages. So everyone needs to do this regardless if you're taking the final exam or not. And just to remind you, the final exam can only help you. So I'll do my very best to try to explain and remind you of some of these concepts and the labs and the demos that we've done to try to trigger some key concepts that might stick in your minds. So let's go ahead and get started. So the first concept is qualitative and quantitative. If you look at the root words of qualitative and quantitative, we have quality and we have quantity. So this is referring to data. So what types of data can we have? Well, qualitative data is dealing things with a description. So qualitative describes. Quantitative is numerical, dealing with numbers. So qualitative data would be things like color. For example, we have this blue fluid. Okay, it's clear. You can see through it. It's not cloudy. Okay, another qualitative piece of data would be dealing with its texture. The large crystals, the hexagon crystals, the square crystals, the surface of a material, its appearance. So those are all qualitative things they describe. Quantitative would be numerical, so we're dealing with temperature like 50 degrees Celsius, or if you have 20 grams, okay, something that is numerical. So that's quantitative and qualitative. Difference between controls and variables in an experiment. So a control in an experiment, this is very, very important. A control is something that stays the same during your experiment. And a variable is the part of the experiment that changes. If you look at the root word of variable, you see the word vary. So this is the part of the experiment that changes or that you're testing. Okay, for example, when we were dropping the gyrocopters from various heights, the control of that, the thing that stayed the same, was the actual gyrocopter. The variable was the height. Okay, so what stays the same? I'm going to just kind of go here. This is the gyrocopter. I'm going to just abbreviate gyro. What changed? The variable, part of the experiment that changes, this was the height. So we dropped it at 3 meters, 2.5, 2, 1.5, 1.5, etc. So that's what was changing. And then we actually changed the experiment where we kept the height the same, and we changed the gyrocopter by cutting off the wings, by stapling them, by adding water to them. Reading and interpreting a histogram. So there's going to be a histogram with a couple of questions on there for you. And so if you can draw this over here, and we are going to have, let's take a look at the favorite color. So we're doing a survey and seeing what are people's favorite colors. And we're going to have, here we're going to have red, and we're going to do the primary colors. So we're going to have blue, and then we're going to have yellow. Over here, we're going to have the frequency. I'm going to switch this a little bit. So I'm going to write in the frequency. And just to remind you, the frequency is the number. The number of times that occurs. Okay, so for example, if we surveyed the freshman class and we find that 9 people, okay, let's say 10 is right there. Let's say 20, here's 10, here's 20, and here's 30. 9 people liked red as their favorite color. Okay, and then we have 27 people liked blue. And then we had 14 chose their color as their favorite color. Okay, so it's red, blue, and yellow. This is the favorite color. Okay, it could also be a piece of numerical data up here. We could be testing, as we did in class, we were testing how tall that you were. Okay, we range between 150 and 160 centimeters, 160 and 170, 170 and 180. So we can do that as well. So we have the heights of 150 to 160, 160 to 170, 170 to 180. So that's favorite color. This is the height. So this could also be numerical data down below here, but this is the frequency. 9 people were 150 to 160. 27 people were 160 to 170. 14 people were 170 to 180. So that's a histogram. Difference between mass and weight. So mass depends on the number of atoms that's within an object. So it depends on the number of atoms. Weight is based on gravity. So if you went out into space, you could be weightless if you're orbiting the Earth, but you're not massless. The number of atoms in your body didn't change from when you're on Earth to when you're in space. So weight is a function of gravity. Your weight can either be less or it could be more. If you're on a larger planet, there would be more gravity pulling you down. It'd be pulling you down on the scale more as well. You would weigh more. If you go on a smaller object like the moon is about 1/6 the mass of the Earth, and therefore it has 1/6 the gravitational pull that the Earth does. So you're going to weigh 1/6 less on the moon. But again, your mass does not change because the number of atoms in you does not change. So the law of conservation of mass. This is stating that mass is neither created nor is it destroyed. Okay, so this applies very well to balanced equations. So we're going to have 2 H2s, 2 hydrogens, and 1 oxygen. And when you combine those together, you create 2 H2O. So in this we have 2 times 2 hydrogens. We have 2 times 2 hydrogens. So we have 4 hydrogens here, 4 hydrogens here. Here we have O2. We have 2 oxygens. Here we have 2 O's. So this is showing in a chemical reaction that atoms are just being rearranged, but mass is neither created nor destroyed. Calculating the volume. Volume formula is equal to length times width times height. And there'll be some metric conversions on the test as well. Let me give a couple of these for you. For example, you have 1,000 millimeters equals 1 meter. Millimeters are very, very small. You got a meter stick, which is like a yardstick. 1 meter is also equal to 100 centimeters. Okay, cent means 100, so if you have 100 of these, You have 1/100th, so therefore you have 1 meter. And also 1 liter is equal to 1,000 milliliters. So you're going to be given these conversions on the test. Conversions are given to you. The question is, can you convert them? So, for example, if you have 463 milliliters, how many liters do you have? Well, if you remember, the proper way to do this is to show your canceling of your units and the units that you're going into. We're trying to go from milliliters to liters. Then you plug in your conversion units over here. 1 liter is equal to 1,000 milliliters. Your milliliters will then cancel, and when you take 463 and divide it by 1,000, that's going to be equal to 0.463 liters. Okay, then we took a look at the energy and molecular motion of solids, liquids, and gases. This is the balloon model. Remember the balloons. So I'm going to put balloons over here. Okay. If you remember when we had all of our balloons pushed together, this was a solid. When we had the liquid, the balloons had a little bit of space between them to move around. And the gases had a ton of space like this. Okay, these guys are flying around like this. They've got lots of space. So here's the motion. These guys are moving fast. These guys are moving slow. These guys are, remember, these guys are shaking. These guys shake. Water, like a liquid water, these particles will flow. And these guys move fast and straight. So with the balloons, we were shaking them with the as a solid. As a liquid, we were moving them and passing them from hand to hand, and then we were then hitting them up in the air as they were traveling very, very fast. So here's the motion, but what's the energy? The energy is going to be low energy here. I'm just going to put E for energy. Okay, liquids have more energy, so these guys have a medium energy. And of course, your gases would have a high energy. Identify the difference between a homogeneous mixture, heterogeneous mixture, and a solution. So a homogeneous mixture, well, a mixture is when you have two substances. Okay, so I'm just going to put 2 or more substances. So you have 2 or more substances. Well, how do those 2 combine in a homogeneous mixture? These are going to be evenly mixed. Homo means the same, meaning they have the same consistency, so they're going to be mixing evenly with each other. Hetero means other, meaning they don't have the same consistency. They're opposites of each other. Okay, so these are going to be separated. To give an example, we have classic example of oil and water. Those don't mix. That's heterogeneous. 2 or more substances that are separated, oil and water. However, homogeneous, evenly mixed, this would be like your milk. Okay, milk has pretty much the same consistency. It's filled with water and proteins and and sugars and fats all evenly mixed together. And a solution is a homogeneous mixture because they're evenly mixed. So a solution is a homogeneous mixture. And this homogeneous mixture has one thing dissolved in another. One dissolved in other. So salt in water would be an example. Salt dissolves in water, and it evenly mixes and thoroughly dissolves and is evenly separated. It doesn't form any type of separation. So that's going to be a homogeneous mixture where one dissolves in the other. Okay, volume displacement. So for this, if you have a graduated cylinder, let's go ahead and draw out the graduated cylinder over here. And you start off with 20 centimeters of water, 20 milliliters of fluid. And you have an irregular object. Okay, it's a rock. You then put the rock in, and it pushes it up to 24 milliliters. So displacement means the water has been moved. It moved from 20 to 24 because of the volume that the rock has, or the object. So you simply take your final volume of 24 milliliters, subtract your initial volume of 20 milliliters, and the difference between those two is the amount of water that it moved up, which was due to the object. So that'll be 4 milliliters. And you can also say, since this is a solid object, here's a conversion for you. 1 milliliter is equal to 1 cubic centimeter. So therefore, this can also be equal to 4 cubic centimeters. Milliliters are usually used for fluids, for liquids, and cubic centimeters is usually used for solids unless you're in the medical field, which they also use cubic centimeters as cc's when they're administering medicines. How to measure a volume using a meniscus in a graduated cylinder. So remember that you're going to be using the bottom. The meniscus is this curvature. So use the bottom of that curve, that water curve. That's the meniscus. That's like that in your graduated cylinder. So let's go ahead and draw a close-up of a graduated cylinder. Let's say the top of it is at 20. Okay, you can't measure from the top, you always measure from the bottom. Okay, so if that's 19, 18, 17, 16, and then you got 15 right here, this would then be 19 milliliters. Okay, let's do another one. If it goes by twos, okay, let's say it was 20. Let's take that one out right here, and that's 18. If it's going by twos, then this is going to be in the middle of that. That will be, of course, 19 milliliters. So boiling point equals the condensation point, and the melting point is equal to the freezing point. We have a drawing over here. You might remember this from our lecture. If you're increasing the energy and getting hotter, okay, let's start off with our 3 phases of solid, liquid, and gas. if you're increasing the temperature and going from a solid to a liquid, you're going to be going through the melting point. Your material will melt, it will now be a liquid. And going from a liquid to a gas, you're going to go through the boiling point. And the opposite, when you cool it, when going from liquid to solid, we're going to freeze it. That's going to be our freezing point. And when going from a gas to a liquid, this is going to condense, or also called the condensation point. So we'll pause here after the first page, and we'll go to the next page.